C++ programming. Of course, that doesn't mean that we learned everything about C++. C++ is a very large, very complicated and detailed language, and I think we touched up almost all the topics of standard C++ 98 and some parts of C++ 11. And there are other major versions of C++, such as C++ 14 and C++ 20. So we will wait until until we know how widely the features of C++ 14 and 20 will be used, and later, if they are popular, then we learn it. So that's the idea. But I encourage you to look at other features of C++ 11, 14, and 20. So one topic that we did not look at before is member pointers. Remember, we talked about some operators this, okay, dot, star, and arrow star, okay, two operators. We did not talk about it. Today we are going to talk about it, and then we are going to talk about C++ 11 features, move semantics, okay? So let's look at this member pointers first. Let me get my pen. I was looking at the wrong place. I found it. Okay, so these two things are the topic of today. So they are called member pointers, data member pointers, something weird, okay? We could use a pointer inside a class, not inside the object. I am talking about inside the class, okay? For example, if I have a data member inside the class, I can refer to that data member using this notation, object dot star pointer, data member pointer, okay, or pointer of that object, arrow star data member pointer. Or we could call functions of an object using the data function member pointers of that class, such as this, okay? This may not make much sense until I give you one example. Let me give you one example here. Okay, so I have a very simple date class. I have my, okay, this is a very stupid simple class. By the way, I have stolen these slides from this person, Zoltan Parkolab. Maybe I am not, I'm certain that I am pronouncing his or her name wrong, but I am sorry, Zoltan. I have stolen your slides and I am pronouncing your name wrong. If you are listening to this, thank you. And I modified the slides a little bit. I skipped some of them. Okay, so this is a nice, okay, all the classes of Zoltan is nice. He's from Hungary, okay, Hungary, and so his examples uses this Hungarian stuff. I mean, not maybe Hungarian, but European. Yeah, okay. So if I have a date, how do I print this date? In Turkey, in Europe, we use this notation. We would say 23rd of March.
So, are we recording?
2. No, I am not. So that means that if I am not recording, Zoltan will not hear me, right? Okay, record here and record. No. I was recording with the OBS, but not with the Teams now. I am recording with the Teams now. Sorry. Okay. So I am posting the YouTube videos, the OBS YouTube videos on the YouTube, on the web anyway. Okay, so in Europe, people use this kind of notation, day, month, and year. Okay, but in US they use this notation. Maybe in Europe they use this dot and like. In US they do this. Okay, so when I call this print function, okay, I want it to print it correctly depending on the region that I am at. Okay, so I have two data pointers. They are pointers of integer. Okay, and I have two data members, integer, okay, month and day, and there is a separator character. Separator will be dot for one case, slash for the other case. Okay, so let's try to use these. Okay, let's try to use these data member pointers. Okay, so this is my setter, integer year, month, and day. I will take it. Okay, and I set it to the year, month to the month. And but when it comes to the print function, it says that print whatever is pointed to by P1, then the separator, then print whatever pointed to by P2, then the separator, then P3. So who's going to set this P1, P2, and P3? It is this HU function or US function. HU means Hungary. Okay, Hungary says that P1 is the address of date of year. So it is weird. We have never seen such a thing before. Okay, I am taking the address of a class data member. Okay, classes they don't have any memory positions, right? Objects have the memory positions, not the classes. But this one is weird. It says that I will take the address of the data member year, then address of the data member month. So P1, P2, P3 is that way. Okay, so P1 is year, P2 is month, P3 is day. Okay, and for the US version, P1 is month, so it is different. Right? See, P1 is the different, P2 is different, and P3 is different. And the separator for the Hungary is dot. For the US, it is slash. Okay. So this one will print if I am in Hungary mode. Okay, this one will print P1, which is in Hungary mode. P1 is the year first, then dot, then month, then day. So this is Hungary mode and this is the US mode. Okay, in my main function, I use this set function to set my date, and then I switch to Hungary mode and US mode. The print function will not change. Okay, the print function is exactly the same. Okay, you might say this is stupid. Why don't I have a boolean that says European or are you guys hearing me okay? It says my connection is not good. Are you guys hearing me okay?
It is fine now.
It is fine now. Let me check my wired connection. I am connected wireless now. What is happening with my wired connection? I don't know. Okay. Okay, so you might say it is weird, but I mean, this is just a stupid example. Some cases you could use this feature, taking a pointer to a class variable. I am not talking about taking a pointer to an object data member. Okay, you could do that too. I mean, you can take the address of this let's say, okay, this is my class. There is a month, day, year, month, day inside each object, and I could take the address of each integer, each object has these three, and I can take the address of each integer. This is different than that. Okay, this is different. Why I am taking the address of the the class data member. Okay, so we could do the same thing with the functions. Okay, instead of, remember those three data member pointers. Okay, these three, where are they? Yeah, instead of these three data member pointers, I will have three function member pointers. Okay, here are my function member pointers. Okay, G1, G2, G3. And inside my print function, I call G1 separator G2 and P3. What is P3? Not P3, it is G3. Okay. Zoltan, are you watching this? I mean, this should be G3, not P3. Okay, so what do I do now in my main function? I set the Hungary mode, and in that case, print is going to work like G1 will be get year. Okay, G1 will be get year, G2 will be get month, and G3 will be get day. So it's like function pointers, but we are talking about the functions of a class. We take the address of a function of a class and use it as a function pointer. Okay, so these are member pointers, two things. So that means that we have learned all the C++ operators. Okay, we have learned all the C++ operators, at least C++ 98 operators. Maybe I did not teach you some of the typecasting operators, such as static cast or reinterpret cast, but they are easy to learn. You can learn them yourself. Okay. Okay, any questions about member pointers? Any questions about member pointers? If you need to use them, and if you see them somewhere, and then this is what they are, and don't get surprised. By the way, I mean, they are not used very widely, and the other thing is that they cannot be overloaded. If you remember our overloading chapter, at the end of the chapter we said that there are some operators that cannot be overloaded. Two of them are these operators. Okay, now let's start a new topic. Okay, we have talked about left values and R values, L values and R values before. Okay. By the way, these member pointers are they are not new with the C++ 11. Okay, we had them in C++ 98, but the things that I am going to talk about now, which is the move semantics. Okay, move semantics will be new in C++ 11, and it is widely used. It has some nice features. Okay, so we know already about this. Okay, we do this kind of stuff. Assignment operator. On the assignment operator, whatever is on the left is an L value. Whatever is on the right is an R value. Okay. Okay, so usually on the L values we have the variables for many languages like Java. Okay, but for the R values we can have all kind of expressions. In C++, of course, we could have, with the help of dereferencing operator. Okay, with the dereferencing operator, we could use expressions like star ptr assignment something. Okay, so the definition of L value for C++ or C is not just a variable. Okay, and we say that on an assignment statement on the left there should be an L value. This is not a valid line of code. Okay, this is not a valid line of code. Okay, so we don't like this. It has to be an L value. So this is a good read. I mean, just maybe I did not give you these slides. Maybe I should give you the slides. Where are my slides now? Let me find the slides. Okay. Okay, so I use the chat to send you the slides. Okay. So this article is a nice article about L values and R values. So up to now I did not say anything new. I already know all of these. Okay. And there are some examples of using L values and R values. I is an integer. Okay. J is a reference to an integer. P is a pointer to an integer. So all these three lines are nice, fine, no problem. I could assign a 99 to J. I could assign an 88 to J. Now the value of I will change because J is a reference to I, right? I know that. Okay, and I am assigning 77 to the reference value of P. Okay, and this is fine too. No problems. I have a function that returns an integer pointer, and this one returns the address of a global variable I. No problems. And this one returns an integer. Okay, but it returns an integer as a reference. Okay, since it returns an integer as a reference, I could use expressions like this. It's weird. Okay, it is weird, but I could do that. It is confusing. Don't do that kind of stupid stuff, but it is possible with C++. And also this one too. Okay, so FP returns a pointer, so I dereference it. Okay, and then I assign the value of 66. So this is an L value, valid L value, and this is an valid L value too. And these are all L values. Of course, these are constants. Okay, these are constants. These are all R values. I know that. Let's look at this function. There is another function f. It takes nothing. It has a local variable k, and it returns a copy of k. It doesn't return the k's reference, right? It just returns a copy of k. Okay, since it returns a copy of k, I can use that copy to make this assignment. This is okay, but this is not okay because I cannot take the address of an R value. F returns an R value. Well, f is not exactly a constant. It returns an R value. Okay, I can take an address of an R value, or I cannot do that. I cannot use R value instead of an L value. Okay, so these two last things are bad things. We already knew about these. So the nice thing about this one is I can make references about L values. I is an L value, and I can take a reference to an L value. So J is a reference to I, and I is an L value. Okay, I could take addresses of L values. Also, I could take references of L values. So C++ 11 says that why can't we have references of R values? Okay, that's the idea. We are gonna take references of R values, not L values. Okay, our regular references for the L values. Now we are gonna take references of R values. Okay, C++ and C, usually we use the value semantics. That means that we work on the values. Okay, we make value assignments. When I say A gets the value of 7, the value of A is assigned. Okay, let's say I have two money objects, money M1 and M2. When I say M1 gets the value of M2, I take the value of M2 and assign it to M1, right? This is a value assignment. C++C has this value semantics. The meaning of semantics of this assignment is value assignment. Okay? But if I keep doing this all the time, it will cause me some CPU time, inefficiency. Okay? Inefficiency. When I copy large objects, this will be inefficient. You might say that if you have to copy something, then you have to do it. I mean, you are going to take that hit. What are you going to do? But in some cases, my objects might be temporary. Okay? Like this. Let me we know the plus operator for strings, right? Okay. If I add two strings, if one of my strings is A, B, C, the other one is C, D, E, okay, this will give me another string. But how about this one? S3, S4, and S5. This one will return a new string. It will create a new string and it will make a new string and it will return it. And I take a copy of it. I will add this one with S3, okay, and this one will return another one, and I will add this one with this one, and this one will return another one. So a total of 1, 2, 3, 4 new strings will be created, and at the end I take a copy of it and I assign it to this S. So unnecessarily I am creating 5 strings. Maybe I have to create those strings, but string is a large object. Maybe there are hundreds of characters in each of them. Right? I keep copying this over and over again, and this is inefficient. This is inefficient. So this is the example that the slides give. There is an array class. Okay, very simple class. It has lots of missing stuff. Okay, it has lots of missing stuff. It says that I have an array, but it doesn't have the number of elements in it. Okay, it doesn't have the proper constructor and the accessor and etc. But let's look at this function, global operator plus. It takes two arrays, left array and right array. Okay, left array and right array. Once I get this left array and then right array, I assign left to result and I add right to result and return result. Well, I did not implement this yet. I'm not going to implement it, but you can guess what it does, okay? It just adds maybe two arrays one by one. Maybe this is an array of double. So if my first array is 1.0, 7.2, 9.1, and the second one is 1.5, 0.2, 3.1. If you add them together, it is 2.5, 7.4, and I think, was this 9.1? Okay, so this is 12.2. This is the addition. Okay, so this one is going to add right to the result and return the result. So every time I do this addition, I make a new array of the same size and continue doing this. How about this operation? Okay, if I have three arrays, a B plus C plus D, so the same thing is going to happen with the value semantics. I make a, this is A, this is B, C, and D. Okay, A, B, C, and D. B plus C is going to make a new object. It is going to be temporary object. Then this plus this is going to make another temporary object, and this temporary object will be assigned to this one. Okay, so there will be total of two temporary objects, this one and this one. At the end, this will be deleted. These two will be deleted. Okay, and every time I do that, let's say my array is of size 1000, I will have this very, very large arrays being created and being disposed of. That's going to be inefficient. But if I use the move semantics, what is the meaning of move semantics instead of value semantics? If I use the move semantics, this is what I do. If I B plus C plus D, if I use the move semantics, the first time I create the temporary object, and then I add this one with this one, and I am still using the temporary object, and then my A is going to point to the data structure of this temporary one. When this temporary object dies, okay, when that temporary object dies, my A is pointing to the array of temporary object. This is move semantics. I still create temporary objects, but their number of temporary objects is minimal. Also, I don't keep making new dynamic arrays inside my temporary objects a lot. That's the meaning of move semantics. I did not tell you how to do that yet, but this is what we are gonna do. We will do this. Okay, don't get scared now. Okay, don't get scared now, because this is our copy constructor. This constructor is used for copying one object into another object. This is our move constructor. Move constructor. Okay. This is our copy assignment, our regular assignment operator. This is our move assignment. Okay. Remember, copy constructor is called by the compiler whenever it is necessary. When you make a call by value, or when you need to make a copy of an object, right? Move constructor is going to be used, okay, whenever it is appropriate. Whenever you need to make a copy of a R value or a temporary object, okay? Again, if you are making an assignment from a R value, then this assignment operator is going to be called, okay? And that operator is a special one. Why? Because it is going to be used on temporary objects by the compiler automatically, okay? And if you like, you could write these kind of operators, okay? Operator plus is going to be used on two regular L value arrays, but this one is going to be used one R value object and one L value object, okay? So you could do this kind of stuff, optimizations, okay? So you're gonna intermix your copy operations with the move operations so that your results will be more efficient. At the end, if you don't use move constructors or move assignment operators, okay, your program will still work fine, no problems, okay? But if you use move operators, move stuff, your programs will be a lot faster. Your programs will be a lot faster. Okay, good. What's going on with this? Okay. Okay, so let's see some examples here. In this case, with the move semantics, I added these two. I did not show you how to implement them yet, but we're going to see a few examples. Okay, so taking an x as a parameter. If you like to take x as a reference, then you need a L value. But if you like to take x as an R value, then you are going to use this. Okay, don't get scared. I mean, this is just notation. These are for L values. These are for R values. And if you like to do a const L value, then it is this one. So let's say I have an X object and I have a function that returns an X object. When you call the function f with an X, okay, which one will be called? This one will be called, because X is an L value. I could do the assignments. Okay. When you make a call like this, okay, G is a function, it returns a temporary object, and that object cannot be used as an L value. I should not use it as an L value. It's an R value. Then this function is going to be called. Okay. Of course, if we know this, if you have a constant L value, then I could use this one. Okay. So it's a new way of overloading our functions. We could send our parameters to the functions using references. Now I am sending them as, okay, R values. Okay, so this is called move semantics. We are going to use move semantics for this. Okay, instead of copying, okay, we are going to steal their resources. If there is this a fx, whatever fx returns will be copied to a, right? And whatever it returns is a temporary object. It will be that, right? I know that. If I do this kind of assignments, this one will call our move assignment automatically. And that move assignment is going to steal the resources of the return temporary object. And I will leave the other object in a destructible state, because I know that the other object is going to be killed in a moment. Okay, in a moment. Okay, so it is up to you. It is up to you how you write your move constructors and move assignments. But the idea should be used for this purpose, stealing the other objects' resources, so that I don't have to create the new arrays, new resources over and over again. By the way, remember our big three rule? Big three. Remember our big three? Okay. Now it becomes big 5. I am writing big in quotes because this big 5 is not as big as big 3, because if you do not implement your copy constructor or your assignment operator, and if you have a pointer in your function like that, you are in trouble, or your customer will be in trouble, right? That's what we said. But if you do not implement your move constructor or move assignment, you are maybe at most trouble in terms of efficiency, not in terms of program correctness. That's why I say that this big 5 is in a quote. So this big is not as big as this one. Okay. So if you are not implementing your big 3s whenever it is needed, okay, your program will not work right. Your program will include bugs. But if you do not implement your big 5, and at most you might be doing some efficiency problems. Okay, unless all the other classes in your library implements these big 5s, and sometimes that may create some problems for you. Okay, good. So let's move on then. Let's move on. Let's see some examples of these classes. Okay, our behavior did not change. I mean, our copy constructors, the assignment operators, and the destructors will behave exactly the same. That is backwards compatibility. When they introduced this move semantics in C++11, they did not break the backwards compatibility. It is exactly the same. Okay. Let me show you one example here. Okay. So let's say I have a class X. I have my copy constructor. I have my move constructor, assignment operator, okay, copy assignment, or and my move assignment. In my private part, I don't know what I have. This is our regular assignment operator. Okay, what do I do with the regular assignment operator? I do all the deallocation and allocation stuff, if you remember. But with the move assignment, okay, what I do is I take the already allocated stuff from this right hand side and make them mine. Let me show you one example from some other source. I think I copied this from Alex Alain. Okay. So he's talking about this move semantics and R value references, and it has there is something wrong with this. There is this half part of this missing. Let me copy this. Okay, move semantics in C++. I think this was the first hit that I think I got it from here. cprogramming.com. Yeah, it is this one. Okay. Let's look at this function and the main function. Okay. I have a vector here, vector of integers, and I use 100 pushbacks. Okay. And I send this vector to this double values function. Since I am using a reference, call by reference, when I send this v to this one, no copying will be made. That's fine. That's nice. No copy constructor will be used. But here I have this new values vector, and this new values vector will be as large as the v vector because I will multiply each element of this. I will multiply each element of this vector by 2. Okay, so I have created a temporary vector and I returned my temporary vector by value. Okay, and I make this assignment. So there will be 2 temporary vectors, and each of these temporary vectors will be created, and each one will have 100 elements in it. And when I am done, I will delete them. So that's inefficiency, right? That's inefficiency. Even though I have used the call by reference, I cannot avoid it. By the way, everybody understood this line, right? So I took a iterator to the beginning of the vector, and did you guys see this? Usually we don't write it that way, right? This one, did you see it? Usually we don't write it that way. How do we write it there? We say that iterator is not equal to what? I mean, whatever we did, this is better than what we did. I mean, the examples that I showed you before. What do we write at this position instead of and iterator?
v.n.
we write v dot and. What does this guy do? This guy says that I am going to have an iterator and iterator, and its value will be v dot end. So he doesn't call v dot end at the end of each loop. This is supposed to be more efficient. Okay, so we don't like this code because this is inefficient. This is using two temporary vectors. So how are we gonna prevent it? I mean, we are not going to maybe prevent the usage of temporary vectors, but we will make those temporary vectors use the same resources, so their creation and destruction will not be that inefficient. Okay, we are gonna see it in a few minutes. Okay, this one says again same thing. This is regular L value. This one returns an L value because X is a global variable. That's fine. Okay. Again, this one returns an R value. Okay. This one returns an R value. Again, this one returns an R value. And I could do this kind of assignment. When I do this kind of assignment, get name. Okay. R value is used in a copy constructor. I copy the contents of this one. Although I am returning a temporary object, that temporary object will be deleted and I will make a copy of that temporary object. So the idea is, why don't I use the resource of that temporary object? Okay, so this is what we do. Get name will return a string, right? And it's an R value. I am taking a reference to that R value. It's an R value reference. It's not an L value reference. Whatever we used before, it was all L values, okay, and L value references. Now I can have R value references. Okay. Previously we could not have anything like that. Okay. We could not take a reference to an R value. Now we can take a reference to an R value. But it is not the same reference as the previous reference. Okay. I have two print references. One of them is this one. The second one is this one. Okay, two functions. Of course, these are void functions. He forgot to put the voids in front. Okay. Void functions. One of them takes a L value reference. The other one takes a R value reference. By the way, nobody is asking me how come I don't use a constant R value references. And very carefully, all of my examples use R value references, but they are not constant. Okay, they are not constants. We will see in a few minutes why we are not doing that. Okay, we will see in a few minutes why we are not doing that. Okay, so let's try to, this is a perfect overloading example. Let's see an example. Okay. This one, okay, maybe I should ask you this. Oh, can I make this without showing the, okay, now. Line 2, which one does line 2 call? The first print reference, line 1 or line 6? And the second one, get name. Remember, get name returns a string. Which one get name calls? Okay, tell me which one line 2 calls. The first one, L value or R value print reference?
It will call line 1.
It will call line 1. Why? Because me is an object and it's an L value, right? Me is an object and it's an L value. I could say me assignment something something, right? So this one is going to call line 1 because it's an object, it's an L value. Get name returns an R value, and this one is going to be called. Okay, this one is going to be called. So C++ 11 compiler knows how to differentiate between these two. And previously we didn't have this difference. Okay, we only had regular call by values, and as the name implies, it's call by value, not move. Okay, now we have ways of doing this call by references, but we are doing the call by reference depending on the L values and R values. This is call by reference of the L values. This is call by reference of the R values. Okay, good. Still we didn't do anything useful. Let's see this example again, an array example. We keep giving these array examples because array examples are fine. Array examples are nice because we could show you this kind of examples, because there is each object in it contains a pointer to an array, right? That's why we have it. Again, very simple example, and it's a broken example actually. It has integer pointer and size, but okay, it has a constructor, nice. It has a copy constructor and it has a destructor, but it doesn't have a assignment operator, which makes the broken class. But for the sake of educational purposes, let's study this class. Okay, again, this doesn't use any move semantics. All it does is copying. Okay, copy constructor, and the default assignment is there. Okay, so this is inefficient. Let's convert this to a version that uses move constructors. Okay, move stuff. Okay, my default constructor, no parameter constructor, it says that if you don't give me anything, I will declare a array of size 64. By the way, this is a very broken class because it doesn't have anything about the number of used elements. Okay, the size is there, but it doesn't know the number of elements in it. Anyway, so this is a broken class anyway. So I am losing this number 64. Where does 64 is there, but where is 0? I did not use any elements yet. And this is a constructor that takes an integer n. Okay, this is our move constructor. Move. Let's look at first copy constructor. Copy constructor takes another array as a reference, and it says that my vals. Okay, my vals be a new integer array, and my size will be the same as the other one. Okay, and I will copy the values of the other array to my pvals array. Since I have allocated enough space, there should be no problem. This is a regular copy constructor, no problem. How about this one? Move constructor. What does the move constructor do? Move constructor says that copy the pvals data member of the other array into mine, and copy the size and make this pvals null. It's so different from what we did. It looks like almost like, if you write such a copy constructor, I would say that this is definitely wrong, because now you are sharing with this one, right? What does line 17 do? You are sharing somebody else's integer array, right? This line is okay, line 18. I just copied it. Okay, so I did not create new space, but I am sharing the space of the other array, and my size is the same. What did I do here? Other.pvals. I am changing the pointer to null of the other array. Can I do that? Can I change somebody else's pointer, integer pointer to null? Does anybody have an idea? I think somebody said something, but I did not understand it. Bahadur, you said something? Bahadur, did you say anything?
Yes, we can change the other pointers to null because the coming object is not
Because the coming object is not what?
constant.
Oh yeah, okay, sure. I mean, it is not constant, but I mean, if somebody is trying to make a copy of itself, and I am changing it, I am changing that, you are gonna go bad. I mean, if I remove this const here, am I allowed to change the copied object? How do I do the copy construction? I will say my array A and B. This constructor is modifying B. It says that the pointer field of this B is going to be null. This is what I am saying right here. Since, yeah, Bahadur says that since it is not constant, I can do whatever you want. Yeah, but you could do that, but should you? This one is nice. It's not modifying anything about this other, but this one is modifying other. How could this happen?
Other is a function, so we can change it. It doesn't matter.
Other is a function. If it's a function, other is a function's return value. It's a temporary, right? It's an R value. Okay, it's a temporary thing. Other is a temporary thing. So there is a function fx. Okay, it will return an array, and that fx, okay, that fx is going to be used as an parameter to this constructor. So this constructor isn't a copy constructor because fx does not return a L value. It returns an R value, okay? That R value is going to be used with this constructor, and since I know that whatever f returns is going to be destroyed in a moment, I say that, okay, I will take your pointer, okay, I will use it, I will make it as mine, and I will make your p-vals null so that you don't delete it. If you delete it, then I will be in trouble, right? And your size will be 0. So I leave other in a destructible state. But in this case, I don't leave other in a destructible state. I cannot because this is a constant. Also, I should not. I should not. Okay. And this is our delete p-vals. And in fact, this would have been better if they checked if p-vals is not null, then delete it. Because sometimes it is null. Good, so this is our first move constructor. This is our first move constructor. And I could do the same thing with the move assignment. Let's write the move assignment. Can we write, should we write the move assignment? Let's write it. Let's write it. Notepad++ somewhere. I am going to copy, make a new file here. Or maybe I should copy the whole thing. Okay, class array wrapper, so that we can get the help from the editor. Control C. Okay, and let me save this as a what? Save as okay, so it's a C++ thing. So let me write a assignment operator. Which one should I modify? Okay, let me modify this one. Or maybe just to make it right, let's write the regular copy assignment first. Okay. Operator assignment. It will take another. Okay. So what should I do? Controls here. Okay. So I am not going to do this stuff. Why? Because these are only for the constructors. So the first thing is, if this is equal to address of other, then just return this, right? That's what I'm going to do. By the way, this is going to be an array wrapper, and let's return a reference so that it is efficient. Okay, if I am same as the other, then I am going to return this. Otherwise, what am I going to do? I will delete my p vals, right? P vals. That's first what I'm going to do. I will delete it, and then I will p vals is going to be a new other size. Okay, good. And then my size, maybe I should do the size thing too. Size is same as the other size. And from 0 to size, p vals I is going to be the same as the other one. After this for loop ended, what should I write at the end? Tell me, what should I write at the end? What should I write at the end? Come on, you did this many times before.
We should return the reference of this.
Yeah, exactly. I should do this. I should do exactly the same as this one. Okay. Okay, good. So this is our regular assignment operator. I should write this, otherwise a default assignment will be generated by the compiler, which will be a bad thing. Okay, let's write our move assignment operator by modifying this. Okay, move assignment will take not L value reference, but R value reference. And I remove this const. Let's not remove the const first, so that you would understand why we need a const in there. Okay. So, do I have to do this now? 56 and 57. Do I have to do this? If this is not other, why did we do this? Why did we do this? So that if somebody says anything stupid like this should not create any problems, right? Otherwise, I would delete my values and I will be in trouble. Okay, so is this possible? Is this possible? I mean, can I myself be the parameter of an assignment operator if I am the R value? No, this is not possible. This is not possible anymore. That's why I'm going to delete this. Okay, how about 57? What should I do with 57? Should I delete my p-vals?
Yes.
Exactly, yes. Why? Because I am pointing to something, but I don't want it anymore. I like to assign some other stuff. Okay, I like to. How about 58? Should I keep it? Yeah. Okay, let's look at this 61. Should I allocate some stuff for me because I have deleted my p-vals? Should I allocate some stuff for me as large as other size?
No.
No, why not?
Because we will take data of the other object.
Yeah. Because we are going to do what? You don't have to be polite. We are gonna do this. We are gonna do, instead of copying, we are gonna steal the resources from the other one. Okay. So I am going to steal the resources from the other one. What am I gonna do? I will do this. I will erase it and I will say other.pvals. Okay. So I am pointing to what the other.pvals points to. And then how about the loop here, 63 to 66? It doesn't make any sense, right? It doesn't make any sense because I am pointing to that one. This loop is going to copy myself to myself. So I am going to erase it. This doesn't make any sense. I just did that. So I eliminated inside this move assignment. I eliminated this costly loop. What did I eliminate? I eliminated that deletion operator. I eliminated the allocation, which is expensive. Also, I eliminated this costly loop. Before I go back, before I return, should I do anything else? Should I do anything else? Okay, should I do anything else before I return?
I think we should assign other p-val with null pointer.
Yeah, exactly. So other dot p-vals should be null pointer, right? Also other dot size, just to make sure that it is okay. Just to make sure that it is in a destructible state, like that. Okay, but look at this one. This is constant. I can't do that. That's why your parameters for the move assignment and move constructors will be non-const objects. Okay, because I am modifying them. Okay, I am modifying them. This assignment operator will not work on the constant objects then. Because if it's a constant object, I cannot change their values, etc. Okay? So this is much more efficient than, okay, this one is line 53. Let me get rid of these extra stuff. Line 53 is much more efficient than line 35. So why don't we use it all the time? I cannot, because this is only for the R values, not for the L values. Okay, this is only for the R values. This will work only for if I have a function, let's say void function. Okay. Okay, void f. Okay, I don't know what f takes, but inside it it will return an array wrapper. I don't know what it is. Of course, this is going to be array wrapper. Okay, so if somebody says that I have an array wrapper, its name is A, okay, and I will assign A to this function, whatever that function takes, I don't know. Okay, so this will not be inefficient. This assignment operator will not be inefficient. This assignment operator will use, okay, we'll call this move assignment, and that move assignment doesn't have any loops in it, doesn't have any allocations in it. Okay, it has just a deletion. Deletion is not as expensive as allocation, and it is much more efficient. It's much more efficient. Good. Okay, so that's the basic idea of move semantics. Okay, move semantics. Okay, what does this guy says other than that? This guy says, okay, I have another class, metadata. I don't know what it is, it's just a very simple class. It has a string in it. Okay, it has a size in it. And it has its own copy constructor and its own move constructor. And it looks like the copy constructor and the move constructor are exactly the same, because I don't have any pointers and that kind of stuff. Okay. If they are the same, I didn't have to implement the move constructor. But it has a point. I mean, this guy is going to give another example. Array wrapper is here. Array wrapper is here. It says that my array wrapper has now an integer pointer for storing my array, and I have my metadata. Inside the metadata, I have the name of the array and the size of the array. Okay, so he's doing something like that. It's not useful, but he has a point. Okay, so my no parameter constructor, I'm sorry. Okay, my array wrapper doesn't take any parameters, and my size is 64, and I am setting my metadata to 64 array wrapper, a single parameter constructor, and my move constructor is here. My move constructor says that, okay, I will just copy whatever the other guy's pointer is, and I will copy the other's metadata. Okay, so I have a question for you now. Okay, line 18, and compare line 18 and line 26. What kind of function call are those? Let's look at the, okay, just to forget about what I teach you today. Let's look at this line 26. What kind of thing is this? What kind of call is this? Line 26. I take an array wrapper object as a reference, copy constructor. I copied a new pointer to some dynamically allocated array to my p-values. But for the metadata, I took the metadata of the other and I do what then? Line 26. What does line 26 do? We copy the other's metadata into our metadata, right? But what copies is this? Is a copy constructor, right? Line 26 is my copy constructor. So line 26 is going to use this copy constructor, right? Line 10 here. Okay? But how about line 18? Just look at line 18. Line 18 and line 26 are very similar. Line 18 says that I am part of move constructor, and move constructor takes a R value array wrapper. So what does line 18 call? Line 18 calls what? Let's go to the code of the metadata. Maybe I should be specific. Does line 18 call line 10 or line 16? Both of them are constructors. One is a move constructor, the other one is a copy constructor. I wish it had called line 16 because it is part of the move constructor. I wish, it had called line 16 because it is part of the move constructor. But unfortunately, it calls line 10 because this line doesn't know that other that metadata is an R value, because it thinks that it's part of a regular object. It's an L value. Okay, it's an L value. So what are we gonna do? We will tell the compiler that this metadata here is an R value. Okay. This metadata here is an R value. How do we do that? We are going to use this function stdmove. Okay, stdmove is like a typecasting. It converts your data from L value to R value. That's simple. Okay, it will force your compiler to think that other that metadata is an R value. Even if it is not, it will force it. Okay, so you have to be very careful here. Okay, you have to be very careful here. Okay, so if you do that, and if you are sure that your parameters is an R value, this will work very nicely and it will be very, very efficient for you. So it's called stdmove. stdmove doesn't do much. Okay, it just tells the compiler. It's like typecasting. Okay, it just tells the compiler that I know what I am doing. Okay, consider this parameter as an R value. You might think that it's an L value, but it's an R value. I know what I am doing. And I will do the same thing with the string of the metadata. Okay, string of the metadata. So we did the same thing. So it says that move assignment operator, do the move assignment operator. You can easily write it. Okay, I already wrote it.
Sure.
Sure.
What
put null in other.p size. Why we even just assign a null if they are just temporary?
Temporary, but the destructor is going to be called on it, right?
Okay, yes.
If the destructor is called on it, it's going to delete this p-vals, and that will put me in trouble because my p-vals will be invalid now. Somebody else destroyed it. Remember why we had written our assignment operators before? Because if I didn't write my assignment operator, the default assignment does the copy, member-wise copy. Then two objects are going to share the same array, and one of them is destroyed, the other one will be in trouble. The exact situation can happen here too. Okay, so that's the meaning of move semantics. Again, this is for efficiency, and it is introduced in C++11, and it increased the efficiency of lots of programs. In fact, after C++11, let me go to STL vector. I don't know how many times I have written this STL vector, and I go back and forth between our programs and the documentation. Let me show you something that didn't make much sense before. Now it's going to make sense. After C++11, they have re-implemented the whole STL library so that they all support move semantics. Okay, all the STL classes they supported their move semantics, and they let me find the constructor of this vector. Where is my constructor? Okay, here is my constructor. Okay, so there are many no parameter constructors. Okay, this is an explicit vector with the allocator. Okay, this is the size of the vector, that I know that one. This is what is the difference between that one and the other one? Explicit vector, size, type, count. Okay, this doesn't take. Okay, this is the same as that one actually. C++11. Okay, so after C++11, they do not use these t-value stuff and allocator stuff. Anyway, I'm not going to look at that one. This one is for the iterators. I am going to find this one. Yeah. Okay. It says that since C++11, I have move constructors. Okay. Since C++11, I have move constructors. And after that, they have this move constructor with no exception. Keyword no exception means that this constructor is not going to throw any exceptions. It has some side effects, and I will not talk about it. But the important thing here is this one. And it has the other variations of it. Move constructor, but it is using the allocator, the allocator stuff. Do I have the iterator version of the move constructor? No, I guess. No, I don't have it. But there is some other example I'm going to show you. Okay, so this is one. And the second one is, of course, the assignment operator of the vector. Where is my assignment? Okay, here it is. Assignment operator. If you go there, you're going to see one example here. Okay. So, see, this is again, this is not constant, right? This is since C++11.12. Okay. And this one is the move assignment, not copy assignment, but move assignment. Okay, good. So all STL supports move semantics. That's why if you compile your code with C++11 compilers, your code might be a little bit more efficient in terms of usage of these STL classes, because C++11 supports the move semantics, Okay, and str class is supposed to move semantics. So copying of temporary data with the C++11 is more efficient than C++98. So your whole code might be faster than C++98 version, even if you do not change a single line of code in your C source codes. Okay, good. Let's go back to this guy's. Where is that guy? Okay, here is that guy. This guy's Alex's notes. Okay. We talked about this print stuff here. Okay, let me go back to Hungarian guy's slides. I think he had a few stuff here. Okay, some rules. Remember the copy constructor. If you don't make a copy constructor, the compiler will make a copy constructor for you. That was the rule, right? If you don't make an assignment operator, the compiler will make a assignment operator for you. That's the second rule. What is the meaning of those copy constructors and the assignment operator? They will do member-wise copy. That's what they do. Okay. Now I am going to introduce a number of new rules. Okay, with the move semantics. The two copy operations, copy constructor and copy assignments, are independent. Okay. The declaring a copy constructor does not. This is going to be not. Okay. Does not prevent compiler to generate copy assignment and vice versa. This is the same as before. We did not change it. Okay. Move operations are not independent. Okay. If you declare the move constructor, a default move assignment will not be generated for you. Declare either prevents the compiler to generate the other. Okay. So if you don't declare anything, your copy constructors, copy assignment, move constructor, move assignment will be generated by the compiler. Okay, so that's the idea. If you declare the copy assignment, copy constructor will not be declared for you, or your default will be declared for you. But if you declare your move constructor, your move assignment will not be declared. Okay, if any of the copy operation is declared, then none of the move operation will be generated. If you do the copy operation, one of them, copy assignment or copy constructor, move operations will not be done. Okay, but the opposite is not opposite. Okay, if any of the move operation is declared, then none of the copy operation will be generated. And if the destructor is declared, none of the move operation will be generated. So if you are doing something like, if you declare your copy constructor, assignment operator, or destructor, your default move operations will not be declared for you. You have to write them yourself. Okay. So these are the new rules with the big 5, not big 3, but big 5. What else? Move operations. Okay. So this guy has this one. Okay. Should I go into? No, not that one. This is a good one. Okay. I don't know if it is true or not, but the C++ standards committee, the committee that says that this is C++11, this is C++14, 17, 20, the committee shall make no rule that prevents C++ programmers from shooting themselves in the foot. Okay, that's valid with the all typecasting operations. And since move is a typecasting operation, that's valid for the typecasting. Okay, so let's look at move now. So this is a good example actually. Let's try to guess what it does actually. Okay, I have a class S. It's a struct S, but it's same as class S. This is my constructor. When you call the constructor, it increments the static count by 1, and it prints out this string S. I have a copy constructor. I have a move constructor. Okay, copy assignment and move assignment. I have this swap stuff. So tell me, what would I produce from this line? SAB. Who's going to be called now with SAB? I will have two objects, so I need constructors. What constructor is going to be called for SAB? It is the no parameter constructor, that one, right? So I will write on the screen S, and after that another S, right? S and S. And the count is going to be, count is a global variable, right? Count is going to be 2. So count has a box in the memory. It's like a global. It's static data member of this class, but okay. Let me make this class and make this public. Okay. So that I can call it a class. Okay. So S and S. How about the swap? When I call the swap, since this is called by reference, right? Since this is called by reference, no copy of the object will be made. So I don't expect this copy constructor to be called, right? Okay. So when I make this one, swap AB, these will be references and no copies will be done. But when I come here, okay, what T? Okay. Tell me, okay, let me do this. Tell me. So this line produces that one. How about this line? What does this line do? Which one is going to be called?
Move constructor.
Move constructor, why?
Because it takes reference.
No. It takes an L value, not R value. Move constructors are good. They work with the R values, not L values. A is an L value, right? A is an L value. So with TTMPA, a regular copy constructor is going to be called, right? So with this one, a copy constructor. So copy constructor says that copy CTR. So a copy constructor, right? Good. And then what? And then A assignment B. Which one is this A assignment B? A assignment B will call what? A assignment B is going to call one of these assignment operators. Is it going to be copy assignment or move assignment?
Copy assignment.
It's going to be copy assignment. Why? Because B is an L value again, right? B is an L value. So it's going to be copy assignment. Okay. B is going to be copy assignment, and it's going to be copy. And the same as this one. Although TMP is a temporary object, I know, but I mean, this is a copy again. Okay. So, well, I mean, this class S is a very simple class. It doesn't have anything large in it. But if I had large stuff in it, I didn't like this copy constructor, copy assignment, and copy assignment. I didn't like those. I wish they had been move constructor, move assignment, and move assignment. So how am I going to do this move stuff? Okay. I will tell the compiler that, okay, consider these as R values, not L values. How am I going to do that? This is how you're going to do it. Okay. This is as copy constructor, copy assignment, copy assignment. So, okay, because these are all L values. But I will force the compiler to think that these are all R values. This is what you do. I move A from being an L value to an R value. B from L value to R value, TMP from L value to R value. This is exactly the same as, let's say you have a void pointer. Let's say you have a void pointer P. I don't know, whatever it is. You could always say, okay, make this an integer pointer. You are not changing the pointer. You are not changing the address. You are not changing anything. You are asking the compiler that P is going to be considered as an integer pointer now, right? This move does exactly the same thing. You are saying that A is an R value, okay? If you do that, okay, of course these, again, this one is going to produce S and S default, but now this one is going to be move constructor, okay? This one is going to be a move constructor, and these two will do move assignment and move assignment. Okay, so you are telling the compiler that I am asking you to consider it as a R value. Of course, you should be very careful about this. You should be very careful about this, because you know how you have implemented. You know how you implemented your assignment operators and the move assignment operators and the move constructors. And if you're doing something dangerous in it, okay, and be careful about those. Because what did we say? If I do this, this copy constructor, move copy constructor will leave A in a destructible state. Okay, that's what it's going to do. Okay, if that happens, and if it is really a destructible state, then you are messing up your object A. But in this case, I am not doing it, but this is a carefully written code. Okay, so std move, the function move, does that kind of stuff. Move has lots of other parameters, and I am not going to talk much about them. Let me see if I am missing anything. Maybe we should look at this one, right? I have 5 minutes, and let me look at this code a little bit more carefully. Again, I have a class S, and everything is public. I have a static integer counter, and its initial value is 0, as I initialize like a global. And every time I call this constructor, a count is incremented once, and A will be assigned to it. And copy constructor, move constructor, etc. So let's look at this one now. What do you expect out of this? I am making a vector, 5 of them. I will make 5 S objects, right? So what does this line print?
Five times no parameter constructor.
Like this one, okay? It will print S, and S. How about this one? First of all, it will call this S, right? After that, we don't know what this pushback is going to do. What do you think this pushback is going to do? Pushback will take that S object that S is a temporary, right? Pushback will take it. It looks like maybe there is a R value pushbacks in there. Are there any R value pushbacks? Let me go to the vector. Let me go there. Maybe there is an R value. If there is an R value pushbacks, that would be very nice. That would be very nice. Why? Because in that case, I am adding just temporary stuff. Okay. Push back as an element. Let's look at the implement. See, there is an implementation of pushback that takes an R value. That means that if you have a temporary object, this pushback is going to be using it. Okay, this pushback is going to be using it. So it is not going to copy it directly using the copy constructor. Anyway, I have this reference anyway, but it is going to make the copy of it. Since I am going to push it back, since it's a temporary, I am going to copy it using the most probably using the move copy. Okay, that's what I am guessing, but this one is going to be called. Then after that, I would expect maybe a move copy, move constructor. Sorry, move constructor. So that's what I am expecting. Of course, if I don't have enough space in there, I may have to reallocate, and I may have to copy all that stuff from one place to another place. That might happen too, because if I don't have enough space in there. And after that, it says that print all the elements of this A with their A numbers. Okay, so this will print from 1 to 6. There are 6 elements in it, and each one, since each one, when it is created, it is created with 1. I think I am expecting it is going to be 1, 2, 3, 4, 5, and 6. So I don't know what am I gonna get after this one, because again, it may allocate some stuff and reallocate it, and after the reallocation, copy it. Okay, I think I had an answer from this one guy. Okay, what does it say? It says 1, 2, 3, 4, 5. Okay, this 5 is going to be from here. This S is this S. This move constructor, again, pushback is using this R value, so it is using the move constructor. And then, okay, 1, 2, 3, 4, 5. See, I have 5 copy constructors. It is taking the copies of old vectors into new place. Okay, and it is showing. I am surprised that it did not use the move constructor. Why it didn't use the move constructor? I don't know. I don't know why it did not use the move constructor. It should have. That would have been more efficient, because it created some new space. Oh no, it cannot. Why? Because I have a new. Yeah, that's exactly. I have a new vector now, new memory, and I have to copy everything. Okay, let me copy. Can I copy this one? How am I gonna copy this? Control A. I was trying to copy this one and paste it to my compiler and compile it just to see it is exactly. It may not give me exactly the same thing, because I don't know how that vector behaves depending on the compiler. But I was expecting that it would use the move constructor. Since we don't know the implementation, we can just guess. Okay, so I guess that's it. I am out of my time. Do you have any questions?
I have a question.
Sure.
Why pushback? Why this pushback is move constructor? Called move constructor. Shouldn't we just put std move in front of s?
Pushback says that, how would you implement the pushback? You would copy this pass parameter to your array, right? There is an object and I have to make a copy of it. But I know that that object is a temporary object, is going to die. So I use my move constructor to copy steal the resources of that temporary object, and I move everything to my array. Now that temporary object can die because I don't need it anymore and nobody's going to use it. So the logical thing would be using the move constructor for this pushback. If it is usable. Let's look at the documentation again. Documentation says that, okay, if I can use it for the L values, I'm going to use this one. Okay. For the R values, if they are constant, then I am going to for the R values, if they are constant, for the L values, if they are constant, no, just look at the C++11 version. Okay. So C++11 version is just this. It just takes a T value. Am I missing something here? Where is C++? Where is C++98 stuff? I don't like this documentation. Let's go to the right documentation. Okay. Which one is good? This one? I think this is the same as that. Okay. Which one did I click before? The first one or second one? What is going on? So I'm clicking on the second one. Okay. Now let's look at this. Pushback is here. So 98 one takes the constant reference pushback. Okay, so 90 C++11 says that I will have two. This is either a constant reference or a R value reference. Okay, constant R value reference or R value reference. If I have an R value, I will not pass that opportunity because that R value is going to die and I will steal its resources. So pushback is smart enough to take advantage of it with the C++11. Of course, C++98 doesn't have that feature. It's just a single pushback. Did I answer your question, Kamil?
So in this example, the move version of pushback is called, but you said earlier compiler doesn't know which one to call. So you said that std move in front of it.
No. Compiler in this case definitely knows that this is a temporary object, right?
How?
Well, I am creating an object and I am not giving it a name. And as soon as this line ends, this temporary object will die. I know that.
Okay. I just missed out that.
Okay. Previously, the example that I gave you, this one, if you look at this line of code, by looking at this line of code, the compiler would not know that, okay, other that metadata is an R value.
Yeah, okay.
Okay.
Thanks.
Okay, good. That's it for today, and that's also it for C++. And I will see you tomorrow morning. We will start our study of Java programming language. So remember everything I told you about C++. I told you a lot, and we are going to use each of them when I talk about Java. I am going to tell you that Java inheritance is the same as C++ inheritance, so that's like 3 weeks of classes for you, okay? And I will tell you that the abstraction and the information hiding and the encapsulation principles are exactly the same. That's it, okay? And I'm going to tell you that Java references are like exactly C++ shared pointers. That's it. And I mean, each of these sentences are like 3 or 4 weeks of classes for Java people. And some of the Java people, actually, they don't know what these sentences are. They don't know what that, even though they are using it, they don't know what the real meaning of it. Since you are good C and C++ programmers, you know you have all the skills required to understand what is going on underneath the Java programs and Java compiler. Okay, so I will see you tomorrow morning. If you have any questions, I will.
Can I ask a question?
Sure.
The last question. Line 23, the destructor of array wrapper. If we don't check it is the p-vals is null or null pointer is
that's what I said. There's not a good code, okay? I mean, I should check if it's a null pointer or not. If it is null, don't delete it. You don't know how the compiler is going to behave.
If it is like this, our move constructor or move assignment.
Yeah.
If it is like this, will we lose the p-vals after?
No, actually, because I assign this null all the time. See, I assign the null to the other object. So if that object is deleted, you are going to call this delete on that null parameter, right? And as far as I know, the compiler's behavior is not known. It might just ignore it, or it might crash. I don't know. Okay? So I guess the author of this page compiled and run his code, but that doesn't mean that this code is right, because for some compilers it might work. So for some it doesn't. Let's in fact look at the C++ delete of null. If I delete, yes, it is safe. There is no harm in deleting a null pointer. Somebody says it. It often reduces the number of tests at the tail of a recursion. Do I need to check? Guarantees that delete will do nothing if p. Okay, so there is a rule. So maybe this is. I am still not sure. Destroying delete. If expression is not a null pointer and the deallocation function is not a destroying. Okay, deleting a null is harmless by definition. So it is in the C++ implementation. That's why this is nice. This is fine. But this is confusing, yeah. So I would have checked it if it is null or not. Okay, any other questions? Okay, if there are no questions, then I will stop here and I will see you tomorrow morning.